All right. Okay, so this is going to be the Algebra 3. This is graph for rational functions. Rewrite these equations. So what we're doing on this is actually trying to make it be the same. Now, the stuff that we did on, I think it was Tuesday. Now, the stuff that we did on Tuesday, you saw problems like this, which said something like 2 over x minus 1. And it's asking about the domain. It's asking about the domain of this. So, and we're talking about asymptotes too. So where is this not going to be allowed? Okay, do you guys remember asymptotes? Okay, something special happens. So, dividing by 0? Can we divide by 0? Say no. No. Please say no. Everyone say no. Okay, no, we cannot divide by 0. So that means in a fraction, I cannot have a 0 in the denominator. So my bottom number cannot be 0. What number will make my bottom of this fraction 0? 1. Okay. So this one right here would be x cannot equal 1, because that is going to give me my asymptote. That's going to be where it's going to be undefined at. So decide if each of these equations are true or false for x values that do not result in a denominator 0. Be prepared to explain your reasoning. Okay, so now there's a couple things that go along with this. So on this first one here, it is of rational functions. We have to be able to combine like terms. We have to be able to understand polynomials to be able to add these together and these expressions. We have to be able to do this. So we're trying to make it look like this, or try to make it look like this. So for this first one right here, it's going to be x plus 7, and the denominator is x. Yes? Okay, so that means that they both terms have a denominator of x. I could separate my fraction in this rational function. I could separate it out. So it's going to be x over x plus, so I'm breaking this apart, 7 over x. So now those together right now have a common denominator. So I can add them together and just be just like this. It's just like this. So now, when I get x divided by x, what does that give me? Not x. What about 5 divided by 5? 1. 10 divided by 10? X divided by x? It's going to be 1, because it's the same thing on top and bottom. Same thing on top and bottom. So that's going to give me 1. So x divided by x is going to be 1 plus 7 over x. So does this first one work out? Yeah. Yes. Now, the second one. Is the second one going to work out the same way? Maybe. I don't know. So what would the common denominator over here be? So I'm actually starting it from this side this time. What would the common denominator on the right-hand side be? There's only one denominator, so that's your only common. All right, here on the right-hand side, the right-hand side of this function right here. What's the denominator? There's only one fraction. What's the denominator is the bottom number.
7.
So yeah, it's going to be 7, right? So it's going to be 7. So that means that the common denominator has to be 7. So it has to be 7 here. So I could actually break this up and actually make it be like that. So now I'm going to rewrite this, and it's going to look kind of funny. So I'm using the same information the way I did this over here, but this is going to be 7 over 7 plus x over 7. Doesn't this look a whole lot like what you have right here, right? Because that 1 right there, 7 divided by 7 is just 1, isn't it? Yeah. So 7 divided by 7 is 1, so I could simplify that now. But I'm not going simplification, I'm going the other way. I'm actually trying to make it more complicated, so they're going to have a common denominator. So that means if they're both the same, I could put it over the same denominator. So they both have the same denominator of 7. So on top, I could write 7 plus x, right? Or, because 3 plus 5 is the same as saying 5 plus 3, that's the commutative property, I could say that it could be x plus. Give me a minute. I'm waiting for this to restart. Okay, there we go. X plus 7. So now, is that the same as saying x over x plus 7? No, that's not going to be the same. It's not going to be the same. And I could even show you reasonings behind this. So I'm going to go through and I am going to do cross products to show that these right here are going to cross out. So I'm going to do what is called cross products. It says if these two are equal, when I go through multiply amount by cross products, they will simplify. So I'm going to multiply this way, multiply that way. So 7x equals, now when I multiply this together, it's going to be the same thing. That's going to be x plus 7 squared. Now, does that look like it's even going to come close to working out? It's not. It's not going to work out here. So in this one, I showed with cross products that they're not going to be equal to each other. But using some ideas with fractions, I can come to a conclusion that this one over here is going to work. So this one does work, and the other one does not. So it's not the same. This right here says, let C be a function that gives the average cost per book. Okay, these are C over here. I don't know if you guys can see that. Average cost per book. And in dollars when using an online store to print X copies of the book. Here's my X copies of the book there. Of a self-published paperback. And so here's a graph of this. Now, as I get closer and closer, so we're just going to look at the graph itself. So I'm going to highlight this in blue so we can see this a little bit better. There we go. So now, as it's getting closer and closer to 0, what is happening here? As it's going closer to 0, what is happening? It's increasing. So what is it increasing? So now, say what it is we're talking about.
Increasing
the cost. The cost is increasing the closer I get to 0. Now, when I talked about that previous problem, can I have 0?
No.
I cannot have 0. Why can I not have 0? Cannot divide by 0. So I cannot divide by 0. So I cannot have 0 in the denominator. So now, if you're trying to print your own book, let's say, for instance, you decide, hey, I had to write a story for English, and it's just that good, I'm going to publish it myself. Okay? This is what it actually looks like. So a couple of different companies, Amazon does it, and a couple of things you could actually find online to publish yourself. So what you could do is, you put in the amount of books. So the more books you buy, the cheaper it is per book. So if you buy 500 books, it's going to be about $4 a book, right? Yes. But if you buy, like, let's say 25 is somewhere in here, it's going to be closer to $10, $11, $12 per book. So that's important. So what is the approximate cost when 50 books are printed? So look at my graph, find 50. What's the approximate cost?
6.5.
About, you say 6.5? Okay. So that we're going to say it's going to be 6.5. I'm going to change it red. So per book. And what about this other one? What about 100 books? $5.25. Okay. Let's say $5.25. Okay. So author plans to charge $8 per book. How many should be printed to make a profit? So now, if the author is charging $8 per book, so I'm going to erase this so I could actually see a little bit clearer. So the author's charging $8 per book. And so to make a profit, any profit at all, how much needs to be printed? How much? Right about here, right? So right about somewhere in here. So there's a couple ways of doing this though. I'm going to show you guys how to do it with the math now. So we were looking at it from the graph from this, so that's approximate, but now we're actually going through and trying to solve for it. So I'm going to insert a page so you guys could actually see this because there's not enough room. All right, so it was, I want $8. So I want my whole cost to be $8, right? And what was the function for that? What was the function? Do you remember what the function was at the top? 120, yeah.
Plus 4x over x.
Over x. There we go. Now we're coming into some algebra here. So now we're trying to get x by itself. But whenever I have a fraction like this, I always get rid of the fraction first. So I'm going to multiply both sides by the common denominator. I only have one denominator here, so it's got to be common. So what's my only denominator? X. So I'm going to multiply both sides by x now. So now it's going to be 8x equals 120 plus 4x. Now I want to get all my x's on the left-hand side. So what should I do from here? Subtract 4x, right? So I'm going to subtract 4x from both sides. So 4x is equal to 120. So again, I'm trying to get the x by itself. So to get the x by itself, what would I do now? Divide both sides by 4. Very good. So I'm dividing both sides by 4. So x is 30. But now, what does x represent? So this is 30 what? 30 books. So that's where you get $8, right? Oh, wrong way. So that's when you break even at $8 per book. So how many should we actually print? Not 30, because 30 is exactly. 30 is exactly $8 per book. If we want a profit, we need to, how about more than that, right? So it has to be more. So x has to be greater than how many books? 30 books. So it has to be more than that. So if you wanted a lot of profit, then you need to, order a lot of books. but I need to know my spot right here. This is where I break even at. I break even at 30 books. So I need to sell more than that to make any profit at all. So if I sell 31 books, I might only make a penny or something per book or something. But more profit, more books, more profit. So what is the value of C of x when x is 1/2? So what does it mean to do that? When x is 1/2. What does it mean I'm doing there? Anyone? What do you think this means right here? Just this part right here. What should I do with it? It says x equals 1/2. What would I do with that information? Do I have a function over here? Yeah. What do you think I should do with x? Yeah, let's plug that in. Let's plug it in. So I'm going to go back to my scratch paper over here. So, and we said x is 1/2. So it's going to be c of 1/2 c of 1/2 120 plus 4 times 1/2 over 1/2. All right, now let's try and evaluate this. So it's going to be c of 1/2 is equal to 120 plus 2 over 1/2. So c of 1/2 is 122 over 1. So I'm going to multiply by the reciprocal because fractions over fractions. Or you could just do it in the calculator like that. So it would be times 2 over 1. So it's 244 is c of 1/2. But what does that mean? What is the 244? What are my units on that? What is the units there? Someone say cost. That's the cost, right? Remember? This is, we're evaluating the function, okay, of the cost as it goes this way, right? Up and down here. So that's what I'm finding. That's what my C represents, is the cost. So that would be now, what does my X represent? What are the units? Books. Can someone tell me why this is not right? People on an airplane. Do you remember the story about people on an airplane? How many people can you have on an airplane? Come on, go back to video. I've said this story a lot. Can you have half a person on an airplane? No. You can't have half a person on an airplane, right? Can you have negative people? No, because negative people get thrown off the airplane, right? Okay, can we have half a book? No, X represent books, right? X represent books. Can I have half a book? No, can't have half a book. So we found the value. Okay, what is the value here? So it was 244, right? Per book, and is it related? And you say no. Okay, it is, can't have half a book. What does the end behavior of the function say about the context? End behavior. End behavior goes to the right. End behavior goes that way. if this function keeps going, is it going to a number? What number is it going to? Positive.
Infinity.
Not infinity. Infinity would be going up. We're talking about cost, right? We're talking about cost. So for going this way, what is the cost going to end up being? Not 1. It's not going to be 1. No. The cost is going to be $4. If you notice, it's leveling out. As it's going right here, it's leveling out right about 4. So it's never actually going to get to 4, but that's where we're going to have an asymptote. Okay, we're going to have a horizontal asymptote. So we had vertical asymptotes, which is x in the denominator, but now this is going to be a horizontal asymptote where it's going to approach some number in the, if I take it all the way out to infinity, if I go all the way to infinity to the right, it's going to be just 4. And I'm going to show you how that works out. So, and let me show you how that works. So, it works out like this. So if I have 120 plus 4x over x, and this is my c of x. Now, I'm going to do what I did in that very first problem. That very first problem, this has a common denominator, doesn't it? Say yes.
Yes.
Okay, it does have a common denominator. So it already has that common denominator, so it's going to look like this. So if I break it up into 2 separate parts, it's 120 over x plus 4x over x. Yes? Maybe? Okay, good. So, now, right here, since I'm trying to simplify this, so the 4x over x, what's going to happen to that? I can take out an x, right? It's going to cancel. So I'm going to cancel those, right? So now it's going to be 120 over x plus 4. Now, this is not something you guys need to know yet. You'll eventually know it, okay? Y'all supposed to be juniors, so by the time you're in college, you might see it. So it's going to look like this. So I'm going to do some calculus math. So we're going to do the limit as x goes to infinity. So it's an easy concept, but I want you guys to actually see the math behind this. So you don't actually have to do this math, but let's take a look. If x is 120, what does this turn out to be?
1.
It's 1, right? So that would be 1 plus 4, right? Okay. So now that's at 120. Okay, so that's not even close to infinity though. It's not close to infinity. So now let's go with let's go 12,000. So at 12,000. At 12,000. So at 12,000. So in your calculator, I want you guys to see what we get here. So you guys can calculate this. This works out pretty well. Yes? Yeah, go ahead. So if I calculated this, what do we get at 12,000? So 120 over 12,000. I'm hoping you people actually calculate like button pushing and stuff like that. Oh, it's restarting? Okay. Anyone have an answer yet?
1
1 over 100. As a decimal, that's going to be 0.01 plus 4. So isn't 0.01 just a really small number? Okay. So now, that's just like 1 penny, isn't it? If you think about it mathematically, that's just 1 penny. So what's happening as the bottom numbers keep getting bigger? As the bottom numbers keep getting bigger, the smaller this gets right here, right? The smaller this gets. So that means that as x gets bigger and bigger and bigger and bigger and bigger, this eventually just goes away. So I like using this analogy. So I'm going to go order 1 pizza per person here. Okay? Everyone gets a whole pizza. That sounds like a good idea, right? So divided by the 19 people in here. Not that many, but still. Let's say 18 and make it round. All right, so 18 pizzas. So that's 1 per person, right? But now, let's go this class and the next class. So that's 18 and 18. But we have the same amount of pizza. How much pizza does everyone get now? Now that we doubled the size of the class. You get half a pizza now, right? So the more we increase the number that we're dividing that pizza by, each person gets a smaller amount. So now instead of the 18, we now have 36. So 36, and I still have my 18 pizzas. So I have the 36 people, now everyone gets half a pizza. Now if I go ahead and add, just my class, and let's go add 9 more classes. That's going to be 180 people. 180 people, but I still only have the 18 pizzas. So if I divide that out, I get 1/10 of a pizza. So that is 1 pizza has to have 10 slices on it. That means you only get 1 slice. So the bigger we divide it by, the smaller you get. But when we're talking about infinity, if this goes to infinity right here, this whole thing is going to go to nothing. Because it's going to be so big when we're talking about in infinity terms, this goes to nothing. So my value is going to be this right here. It's just going to be 4. Okay, so. Now, horizontal asymptotes. Horizontal asymptotes. So let's take a look at what we have. So for this first one right here, A, there's supposed to be a horizontal asymptote. Now, where is this one right here? So using that same information I just went over, where's the horizontal asymptote on this one? At -1, right? Because as x goes to positive infinity, as x goes to infinity, as it keeps increasing, this number right here is going to go away, so my asymptote is going to be at -1. So let's go ahead and take a look. So that one's going to be right here. That's going to be right here at -1. What about B? Let's look at letter B. There's going to be a horizontal asymptote. Where's the horizontal asymptote going to be at now? -4. So which one of that is -4? B. All right, there we go. Now C, it's not separated, right? So can we separate C? Say yes. All right, let's do the math on it then. So if I break it apart, because they're common denominator, it's going to be 1 over x, very good, plus 4x over x. What's going to happen to those x's? Cancel. So my horizontal asymptote is going to be at 4, at +4, right? So what letter is that? That's A. All right, let's look at D. That one's not broken up either, right? Can I break it up? Yes. So where's that going to be at? Rewrite it. Rewrite it first. So common denominator, if I rewrite that, that's what over what?
X over X.
X over X.
Plus 4 over
4 over
X.
X.
In
My X is canceled, don't I? So that's going to leave me with 1 right there, right? So now the 4 goes away. The 4 over X is going to go away. So this is going to leave me an asymptote at 1. So at 1. Positive 1, which would be letter C, right? Okay. Now can we do the same thing for E? Okay. So where's the one for E going to be?
-4.
At -4, and that letter is B?
B.
Very good. How about F?
At 4.
-1.
Yes, it's going to be -1, right? It's going to be -1 because it's negative X over positive X.
Yeah.
So that's -1. So my answer is D. What about G?
1.
At positive 1. So my letter is C. And H is at 4. So my letter is A. Where do you see the horizontal asymptote of the graph in the expressions for the function? There we go. It's always when I break it up, right? Because the limit as 4 over X goes to infinity, that wipes out and goes to 0. But then you get whatever constant you have right there. So if you wanted to put the stuff that we did right here on this, if you guys didn't write that down, the limit stuff, you could put that there. All right, so consider this one right here. Predict where do you think the vertical and horizontal asymptotes are. First, let's start with the vertical asymptote. A vertical asymptote was when? If you can't remember this off the top of your head, you're going to write it down on your notes, right? Vertical is up and down, right? Vertical is up and down. Okay, and there's something that I cannot have, which gives me a vertical asymptote. 0, right? 0 in the denominator. Okay, so no 0 in denominator. No 0 in denominator, so if I do the math, watch this. X minus 1 equals 0. We could just see where it's supposed to be at. So eventually you're going to get some more confusing expressions than just this. You could see, oh hey, it's 1. 1 minus 1 is 0. Or I could set the bottom equal to 0. Set the bottom equal to 0. So add 1, x equals 1, right? So that means that that is where my vertical asymptote. All right, now let's try the horizontal asymptote. So let's see if we can break that up. So it's going to be 1/2 x plus 1. And I'm going to go like this over x minus 1. All right, so I'm going to break this up now. So watch this. So this works out. So there's a plus sign on top. So there is common denominator. So it's going to be my 1/2 x over x minus 1 plus 1 over x minus 1. All right, so where do you think that one's going to give me a horizontal asymptote? a guess.
One.
At 1? Maybe. So if I think about going to infinity again, right? What's going to happen to this? What's infinity minus 1? It's still infinity, isn't it? So is this still 1 over infinity? Yeah, it's still going to be 1 over infinity, isn't it? So this part right here by itself becomes what? Remember, we're dividing by a huge number. What happens if we divide it by a huge number? It's going to be 0. It's going to go away. It all goes away if it divides by a huge number. So it gets so small, we consider it 0. So this is 0. But now, if x is infinity, that is 1/2 times infinity minus, what is infinity minus 1 again? It's still just infinity, isn't it? And what do you think infinity divided by infinity is? 1. Very good. That is 1. So infinity divided by infinity is 1. So those will cancel out. So what am I going to be left with at the end? Just 1/2. There we go. I have 1/2 plus 0, which is just going to be 1/2. So this is step by step on how to actually get this. So even if this was plus 1 or plus 10, infinity plus 10, guess what? That's still just infinity. It's a multiplication that actually changes it up. So if there's a multiplication, then I have to account for the multiplication. But this is exactly how I do this. So now, that means, I think I'm done with that, yeah. So we're going to take a look at the graph. Taking a look at the graph on this. Actually, before I go too far, what page number did I actually have on this? What page number was on the notes? Let's say 55? Make sure I actually put that. So this is notebook 55. So we're plugging it into the calculator now, so hopefully everyone's doing that while you're waiting on me. So you're plugging this function right here into the calculator. We're going to look at the graph on that. So you guys are looking, so you have to actually pick up the calculator. You have to turn the calculator on. Yeah. Apparently the sub or someone unplugged it on my thing. So yeah, a lot of people's calculators are dead. So hopefully you have your calculator in your hand, plugging it into your graph, not your phone, your graph. Graph.
What page?
Graph 55. So right here, I'm going to set up my problem. So let's go control, divide, there we go, 1/2 x, right? And plus 4. Oh, no, plus 1.
Oh, plus 1.
Over
X minus 1.
x minus 1. Go, let's see what my graph says. Hey, where did we say the asymptote was? The vertical asymptote? At positive 1, right?
Yeah.
At positive 1. Let's see if I could show that. So I'm gonna do a trace. You guys don't have to do this. I'm gonna just show you. So at positive 1, so let's see, positive 1, hit enter. There it is. It is undefined. So right here, what do we say that there is a horizontal asymptote at? 1/2, isn't it? So I'm going to show you guys. So I'm going to go 0.5, enter. There it is.
there's my horizontal asymptote. Horizontal there, vertical there. Alright, so hopefully that helps you guys out. Don't forget, like, share, and subscribe.